Hi everyone, welcome to this tutorial in my channel. We are asked to solve this quadratic equation 5x squared plus 3x minus 2 equals to 0. We want to solve this quadratic equation using these three methods. The first method is the factorization method, then the second method completing the squares, and then the third method the quadratic formula, using the quadratic formula. So without wasting time, let's take the first method, which is the factorization method. Now we have 5x squared plus 3x minus 2 equal to 0. Okay, we see that the coefficient of the leading term is not 1. So what do we need to do? We find the factors of the coefficient of the leading term and the constant term. And so factors of the product of the coefficient of the leading term and the constant term. And so we'll find that product first of all. 5 multiplied to negative 2, this 5 multiplied to that negative 2, we're going to have negative 10. So we're going to look into the factors of negative 10. We first of all list out the factors of negative 10. So we can have plus minus 1, plus minus 2, plus minus 5, plus minus 10. These are the possible factors of negative 10. Now, in this set, we are going to choose two elements such that their product is negative 10 and their sum is positive 3. This term, the coefficient of the x term. Okay? So, our choice, therefore, will be, if we look carefully, our choice should therefore be uh, positive 5 and negative 2. So we choose 5 and negative 2. That should be our choice because the product is negative 10 and the sum is 3. Pay attention. The product is what we have here. The coefficient of leading term and the constant term, negative 10. The choice that we make here should be such that the product is that negative 10 and their sum is the coefficient of the x term. That choice is only 5 and negative 2 and nothing else. So now we're going to rewrite this equation. We're going to rewrite this equation and then instead of 3, we're going to write 5 minus 2. All of that multiplied to x. Then minus 2 equals 0. We open up this bracket. We have 5x squared. 5 multiplied to x plus 5x. Negative 2 multiplied to x minus 2x. Negative 2 times negative 2. That gives us, oh, sorry, please. Uh, we are opening this bracket with respect to x. 5 multiplied to x, 5x. And negative 2 multiplied to x is negative 2x. This negative 2 is not concerned with this bracket. So we leave it there the way it is. Okay? Now, to check to be sure that what we have done is correct, let us simplify this and see if we get back that expression up there. So we have 5x squared, that is it there. 5x minus 2x, 3x, and then we have negative 2. So we are good. Now let us start factorizing. We factorize the first pair, and then we factorize the next pair. Here we have 5x is common. 5x into x plus 1. And then here we have negative 2 is common. Negative 2 into x plus 1 equal to 0. Again, once more, you should always check to be sure that your factorization is correct. If we multiply this out, do we get that one there? 5x multiplied to x, 5x squared. 5x multiplied to 1 is 5x. So this factorization is correct. Let us open out this bracket and see if we get back up there. Negative 2 times x is negative 2x. Negative 2 times positive 1 is negative 2. So this factorization also is correct. Now at this level, we'll find x plus 1 common. So again, factorization process continues. We have x plus 1 common. When we remove x plus 1 from here, we're left with 5x. When we remove x plus 1 from here, we're left with negative 2. Okay, now we have this factor multiplied to this factor giving us 0. All right, this product giving us 0 means either x plus 1 is 0 or 5x minus 2 is 0. Now, if x plus 1 is 0, that implies that x is negative 1. And if 5x minus 2 is 0, that implies that uh, 5x is equal to 2. We'll divide both sides by 5. We have x is equal to 2 all over 5. So these are the two solutions for that quadratic equation. We're supposed to obtain two solutions because it's a polynomial of degree 2. So we're supposed to have two roots. The first root, x equals negative 1. The second root, x equals 2 all over 5. Okay? Right? So you can pause the video and you attempt solving it, and then you cross-check your work. Now, let's take the second method, which is completing the squares. So we take off this. Let's take off this. Okay, the second method, by completing the squares. Let's write the equation again. 5x squared plus 3x minus 2 equal to 0. We want to use the completing of squares method. The very first thing to do with completing of the squares method is to check to be sure that the coefficient of the leading term is 1. So to make the coefficient of the leading term 1, we are going to divide all through by 5. Okay, so we'll come here, we'll divide by 5, divide by 5, divide by 5, divide by 5. That's going to give us x squared plus 3x all over 5 minus 2 all over 5 is equal to 0. Okay, so now the coefficient of the leading term is 1. Next, we carry the constant term to the right hand side. So we have x squared plus 3x all over 5, negative 2 all over 5, carrying it that way, it becomes positive 2 all over 5. Now, next, we add half the coefficient of the x term squared to both sides. Now, this is what we're saying. Half the coefficient of x term here is 3 all over 5. We're going to add this on both sides. So first of all, evaluate it. Half this squared. So we have, nothing can cancel, so we have 3 all over 10 squared. So we have 3 all over 10 squared. That gives us 9 all over 100. So we're going to add 9 all over 100 to both sides of this equation. Now, this gives us x squared plus 3x all over 5 plus 9 all over 100. We've added to the left-hand side. We do the same thing to the right-hand side. 2 all over 5 plus 9 all over 100. Now, if we look carefully, the left-hand side is already a complete perfect square. It's a perfect square. It is actually x. It is actually x plus 3 all over 5, 3 all over x all over 3 all over 10 squared. This left hand side, it is x all over 3, is x plus 3 all over 10 all squared. Okay, now the right hand side, let us simplify. The LCM is 100. 100 divided by 5 is 20. 20 times 2 is 40. So that gives us 49 all over 100. So pay attention, we are solving for x. To remove this square, we take square root of both sides. When we take square root of both sides, we're going to have x plus, we're going to have x plus 3 all over 10 is equal to plus minus 7 all over 10. The square root of 49 is 7. The square root of 100 is 10. So x plus 3 all over 10 is equals to plus minus 7 all over 10. Now, to have x, we have to carry this 3 all over 10 to the right hand side. Now this will give us plus minus 7 all over 10 minus 3 all over 10. Alright, so the first value we take the plus, x equals 7 all over 10 minus 3 all over 10. 7 minus 3, 7 minus 3 is 4. 4 all over 10 gives us 2 all over 5. That is our first solution. And the second will be, we take the minus, negative 7 all over 10 minus 3 all over 10. Now this gives us negative 10 all over 10, which is negative 1. So again, our solutions are x equals 2 all over 5 and x equals negative 1. All right, so that is the working when we use the completing of squares method. Again, pay attention. We start by making the coefficient of x squared 1. That's the first thing to do. Divide all through by that. Next, we take the constant term to the right hand side. Then next, we add half the square of the coefficient squared on both sides. So half of 3 all over 5 all squared. That gives us 3 all over 10 squared, which is 9 all over 100. We're going to add that to the left hand side and to the right hand side. That's it there. And then now we carefully look at this. We must obtain a perfect square. And that perfect square, therefore, from careful examination, it is x plus 3 all over 10. If you want to check if it is true, you open out this bracket. Take x plus 3 all over 10 multiplied to itself. You're going to get out this expression. If you don't get back this expression, it means your analysis to move from this step to this step is wrong. So you have to reconsider what you did and do it perfectly well. Now, so then we add up this fraction here, we get that. So to get x, remember we're solving for x, so to remove the power 2, we take square root of both sides. And so we get this expression. From there, we now simplify down to have x equals to 2 all over 5 and x equals to negative 1. So that is it using the completing of squares method. Now the last method is using the quadratic formula. Let's take off this. We now use the quadratic formula. Now, see, we still have the equation 5x squared plus 3x minus 2 equal to 0. We want to use the quadratic formula. Now, the coefficient of the leading term is always given the letter a. You know, the standard quadratic equation is ax squared plus bx plus c equals 0. So, a is a coefficient of x squared, so a is 5. B is a coefficient of x, so b is 3. And c is a constant term, c is negative 2. Okay, the quadratic formula says the variable here is x equals to minus b plus minus the square root of b squared minus 4ac, all of that divided by 2a. Okay, so let us put our various values there. So we have negative 3 plus minus the square root of 3 squared minus 4 into 5 times negative 2. All of that divided by 2 times 5. So that gives us negative 3 plus minus the square root of 9 minus the negative become positive. So say plus 4 times 5 is 20. 20 times 2, 40. All over 2 times 5, 10. So that gives us negative 3 plus minus square root of 49 all over 10. All right, negative 3 plus minus square root of 49 is 7 all over 10. So finally we have x equals, we take the plus, negative 3 plus 7 all over 10, which gives us 4 all over 10, which is 2 all over 5, or x equals, we now take the minus, negative 3 minus 7 all over 10, which is negative 10 all over 10, which is negative 1. All right, again, we obtain the same answers as with the previous two methods. So that is how we use the factorization method, the computing of the squares method, and the quadratic formula to solve the quadratic equation. A quadratic equation is a polynomial of degree 2. So we must always have two roots or two solutions or two zeros.